You still can't see that, I'm sorry. So what you're going to see here, you guys are building a pie chart in Excel for Wednesday. It's a pie chart in action. What I'm going to have is I'm going to have Excel roll dice for me. So for instance, when you asked about the iPod randomizer, a very easy way to do it is to use this command. If you click in this cell, you'll see it. It's called rand between. That's Excel's die roll command. Rand between, and then you put a 1, comma, and then whatever the highest number on your die is, close parentheses, press enter, it rolls a random number. Every time I press the F9 button, it will roll a new one. Hang on a second. There we go. There we go. There we go. There we go. I just rolled it 6 times. Notice what I got? 3 4s, a 3, a 2, and a 6. Careful with that statement. We just disproved one of the early votes for what a 1 in 6 chance meant, didn't we? One of the first votes we had for a 1 in 6 chance was every 6 times you roll a die, you get 1, 3. That was one of the early votes, yes? But then we said we had to add something on average over time. Let's roll 6 more times, shall we? Taryn, go ahead.
I'm just confused. How do you know when you have like enough time?
You're taking 243, aren't you?
Yeah, I am.
Yeah, you are.
I know what you're looking for, so you know.
Did you hear that awesome question?
But if you don't know what you're looking for.
You're taking 244 too, aren't you? Yeah, she is. You see, the question, I'm not doing that just to sell 243, 244, but you're asking a question we get to in that class. How many times do you have to do it? What you're asking about is something called power of a statistical study. Believe it or not, I'm in the process of typing a letter right now to the Mars Corporation. Because the Mars Corporation makes M&Ms. And one of the last things we do in 244 every term is we crack open a bunch of bags of M&Ms and we check their colors against what the percentages of colors are they say they should be. They tell us there should be 13% red, 13% brown, 24% green, something blah, blah, blah. I got it all written down. So I get a bunch of bags of M&Ms, give them all to students, we crack them open, we count the colors, and we see if they match. Guess what happens? No. They never do until last Thursday.
Oh my God. What?
Yes. Well, exactly. I'm sitting there watching the numbers come in, and I'm just like, and I'm like, a little bit drool. And the kids are like, are you okay? And I'm like, I couldn't talk for a couple minutes. Because I've been collecting this data for like 10 years. And it never matches. And then I'm like, and then it matched almost perfectly. And I'm like, son of a bitch. Now, the problem, it was a false negative most likely, which means they're still off. We just got data that just so happened to make it look like it was on. Which brings back Taryn's question. How many would we have to have selected to truly see the underlying? So, we will journey through that journey in 243 and 244, my friend. But watch this, 6 more times. Look, I've done it 18 times now. Look at those, all 6 slices are in there now, yeah? All 6 slices are in, 1, 2, 3, 4, 5, 6. But they are nowhere near 1/6 each, are they? So to visually illustrate what Taryn's talking about, I'm going to hold the F9 button down and let it keep going. Look what's happening as we go. Isn't that rad? I think this is like the best way to see what 1/6 means. Say that again. Say that again. No, please, please. No. Oh, it was such a good scene. Matt, go.
Is there something about like a trial has to run a certain amount of time?
And the question is, what's the cutoff, right?
But like equivalent to the odds of the trial?
Yes, it's all tied together. It is all tied together. The trick is, and I love what both of you guys are asking about because it's so important. When we roll a die, it's kind of cheaty because we know how many sides a die has, right? When you survey a population, first of all, you might not know how many sides the population has. Even if you give them a set number of choices so you know the sides, you're not sure what percent are going to pick each one of the sides. So suppose, for example, you say, who are you going to vote for in the Democratic primary in 2015, whatever, 2016, and you give them a list of 4 people. You can't assume that 25% are going to pick each one. So you do the survey to collect the percentages. But what if you only run it 100 times? You might not get enough to do true percentages. That's Taryn's question. That's a great one. It's a great question, but it is past 105, unfortunately. Go ahead, Michelle.
So it's the way when you just sit there and just holding it down and
Yes, ma'am.
the numbers go. It's the same thing as when you held down the button when we did the whole orbital thing.
It's exactly the same thing.
Starts to level out.
Yes. it begins to approach the true value. I'm going to stop it right here. It's at 3124. 3124. Let's get to a nicer number. Let's get to a nicer number. Now it's at the 3600. Go ahead, Tammy.
So where it says P with the X, is that supposed to be the percentage?
Yes, percentage of probability.
So how come none of them make...
Hold that thought. Hold that thought. That's what I want to get to right now, Tammy. Thank you. No, it's a great question. Tammy's got the next point. Let me stop at 3600 real quick, just because the math will balance. Oh, crap. I missed it. No, let's go to 3612. That'll be that. Okay. Now, why am I saying... I'm trying to get to a multiple of 6. So, if we have rolled this thing 3,612 times, how many times should we have seen each number if the 1/6 was acting exact?
602.
602, right? 602. 1/6 of that total should occur in each if it was behaving perfectly. Now notice, 585, 581, 561, 623, 635, and 627. None of them are exact. None of them are exactly 602. But realize how far they're off. Hardly at all. Now Tammy has noticed over here, if you go to this over here, these are the percentages. 16, 16, 16, 17, 18, 17. They're off, yeah? What I'm going to do is, while you guys take your 5, I'm going to stick my stapler on the F9 button, let it hold it down, and let it keep going. When you come back and I've got 10,000 trials, take 5, we'll come back and start rolling those dice, looking at those coins, and we'll answer some more questions, hopefully. Yes. Yes. Let me turn this off.